Hey, welcome back to the second part of the presentation. In the first part, we talk about what a few points on the application security, the challenges, give a formal definition, and we talk about a few case studies. So in this section, we're going to look at two versions of implementation we did in ping identity to basically to how to generate those test cases and how to make them visible. So previously, we talked about the test cases are really decided by security control. So the question is, how do we know which security controls we should use? Anybody want to give a try? How do you know which security control we should implement?
Of some design work in the threat modeling phase. Once you identify the threats that the application will face, you want to make sure you have controls to address those threats. And also may come from a security requirements perspective when it comes to security functional controls.
Yeah, that's totally correct. So basically, let me mention about threat modeling, threats from threat modeling, and also from the security requirements. So here I just combine it into one thread. So even for the security requirements, or it may come from the compliance standard, regulation, etc. But ultimately, we want to mitigate the threats, right? So I just use a threat here. Where do threats come from? It's usually from threat modeling. So just another survey on the audience who do threat modeling. Okay, may I ask you, how do you use your threats after you finish your threat modeling? Do you follow up? How do you make sure that they are actually used? Who wants to go try? Here.
So the threat stories have corresponding controls or safeguards, and we create tickets in Jira, for example, to implement those. And once they're embedded into the work order system, a Jira ticket then gets tested, so it's part of the workflow.
So based on a threat, someone will create tickets for the control, corresponding control, and your control will be automatically tested. And who are responsible for specifying the test cases for these controls? Just curious.
The test team.
Testing. So previously, I think you asked the question how to handle the misuse case, right? That's the question. So here, I think for test cases, in test security controls, it's better to specify in a positive requirement instead of test negative requirement, because it's really hard to test those negative requirements. For example, you want to say, no unauthorized user should log into the system. How do you test this? Instead, if you say, if there are 3 failed tries, then the account should be logged out. And that would be much easier to specify the test case. And I think this is a better approach for creating test cases. And in terms of flow, the basic flow is similar to what you said. Usually security teams specify the threats through threat modeling. Then pass to the dev will create the test cases. Then test cases will be run in Jenkins, and the test result, in our case, in our first version of implementation, we will upload to Google Sheet in order to have some visibility. The reason we upload to Google Sheet is we can do some analytics and also can give us an inventory of all the security controls in our system. So here is an example of the Google Sheet. It's pretty small. Maybe people in the back of the room couldn't see it. I will just describe the general idea here. The first 3 columns, they describe the threads. The first column is data flow. For example, the first row says from client to admin API. Second one is the thread ID. Basically, this is a UUID that is used to correlate the test case to the thread. And the threat description is more for human consumption to describe the nature of the threat. And the test case really come from the test case class package. So for the test case, last run test result, build URL, and these columns are automatically generated by Jenkins build and uploaded to Google Sheet. So essentially, security team owns the first 3 columns. We specify the threats based on our threat modeling. Then the rest columns are owned by dev team. So this is really, I feel, a good way for security and the dev team to really collaborate, to work together. So based on the Google Sheet, you can generate some chart. And in this case, we basically calculated the coverage of the test case, which really means how many security threats have corresponding security test cases. We find it's also a good motivator for developers. There are several occasions that we create the Jira tickets, ask the developer to create a test case. And while they are working on the test case, they will often come back to this Google Sheet and observe, oh, the chart is getting better coverage. So it's a good visibility and motivation for them as well. So a little bit details here. In order to track all the test cases, internally we developed a library that has custom Java annotation. In this case, it's called the threat. It has 2 attributes, description, which is really the description in the Google Sheet that you saw earlier. And ID is really the UUID in the Google Sheet. And we also implemented JUnit and test engine listeners. So the listener, when the test is run on the Jenkins, it will listen for all the test cases with this annotation. And it will capture those test cases. And then in the third step, we will use the Google Sheet API to upload test cases to the Google Sheet. This is what you saw earlier in the previous slide. Any questions here? Okay, there.
Do you use a standard taxonomy for your threat descriptions? For example, the stride model that comes out of the threat modeling tool from Microsoft?
I will, yes, we do use that one. But I don't know what you mean by taxonomy. I will stride mainly is a mental model to help you to consider, to take into account different threats, like a spoofing, information disclosure from different angles. So as the real threats, it really depends on the application logic, right? So for the first one, we have a brute force authentication. So this one can be viewed as information.
I think Martin's question is, do you have a common catalog that you consistently use? Just saying, I think Martin's comment is around, do you have a consistent catalog of threats that you use, and where do you derive that from?
Yeah, we follow the stride model, yeah. But we do not put all the enumeration here. Usually we focus on the most important one based on our application. For example, for spoofing, if you use spoofing, then a lot of cases you need to specify TLS, right? Usually it means TLS, but we know our application, all of them are already using TLS, so there's no point to specify a threat here. Okay. So there are many benefits of this approach. I remember before we had this Google Sheet, once we got a request from customers asking, please show us all the test cases you use to make sure that our data is separated from other users' data. And we had to scramble, and took us quite a amount of effort in order to collect all the test cases we have. And with this approach, it's very easy to see which test cases we can show proof to customers. Also, so this is the first point, to provide visibility into the existing security test. Also, we can provide inventory on the application security controls. So basically, each test case can link you to the corresponding security controls, and can also motivate dev team to create more security test cases because due to the visibility. Also, it can hold security team accountable. So it's very visible to see how many threads security team created for an application. Also, it promotes close collaboration between dev and security. Very often, we found that it's easy to come up with the thread, but usually there are several back and forth with the dev team to decide how should we test it, what's the best way to test that thread. So this is really a conversation with the dev team. And also, last but not least, we can detect the missing or broken security controls early on, like the LDAP empty password issue you saw early. We can detect in a few hours. And also similar for the sort, password sort. If we had this test case to make sure that the sort generated by our hashing function has look different, has different values, then we would be able to detect this immediately. Wouldn't have to wait for 2 years to fix it. Question.
Number one, where the salt was being reset or cleared, how would that test case have been any different than a unit test for that particular piece of code?
So you're assuming there's a unit test for it? So what kind of unit test are you envisioning?
Well, if let's say you're putting in 2 passwords,
Yep.
and you're putting them through the hash algorithm, you would expect 2 different hashes if the salt was functioning correctly.
Yes, that's some test case I would expect. But the problem is even that kind of test doesn't exist.
Okay.
I don't think, I don't know. We shouldn't assume that the dev team can always create that kind of test case because it doesn't affect the functionality. Unless you ask for it explicitly, it may fall in the crack. There are a few limitations right now. So the first one is right now one thread can only have one test case. You can use the annotation both on the method and class. So that's one way to get around it. And some threads don't lend themselves well to test case. It's kind of positive requirements. So again, how do you use test case to check all the cross-site scriptings? I think earlier we had a comment for some attack, for example, secret injection, directory traversal, or cross-site scripting. There are many different payloads, right? It's impossible for you to enumerate all these different inputs. I think that in those kind of cases, the key is to make sure at least the encoding is working correctly. For example, SQL injection, we need to make sure the prepared statement is used. For cross-site scripting, we need to ensure that actually the encoding, hopefully you're using centralized encoding mechanisms. We need to make sure at least that encoding is working correctly. But it's unrealistic to expect that the test case will cover all the parameters or input to make sure they're all encoded. 3.
I think these kind of attacks can be detected by the automated tools. They do pretty well. So coming back to the original question of collaboration, so automated tools plus functional testing will actually make the coverage better.
Yeah, I totally agree. So the best combination is to make sure the functional test to use functional test to make sure the encoding is working correctly, and use the tool to make sure the different inputs parameters are covered. Okay. Also, not all the threads have the same priority. Right now, it's not accounted for, so we treat all the threads have the same priority. The next one is how to measure the effectiveness. How do you know your security functional testing is contribute to is finding issues? Previously, we have a slide to show the coverage. That's only shows you the effort, right? The activity you have. But ultimately, you want to know, maybe your boss will ask you, how many issues, security issues are identified by security functional testing? Right now, we don't have a good way because this can be integrated in both unit integration or system test. And sometimes the developer can run the test on their own machine before even checking into the source control system. This is something we want. We want to prevent the issues from happening early on. But the trade-off, the flip side is how do we measure the effectiveness of these test cases? It's over there, yeah.
So I don't see it kind of covered on this limitation here, but one of the things I'm curious about in your model, who writes the security tests? Is that the testing team or is that the security team?
Right now, we rely on the dev team to write or testing team to write.
That's one of the problems I think, or one of the concerns I have is that ultimately we're all starting to evolve or devolve, dependently on your perspective, into almost exclusively development. And you have that development skill set almost needed to do some of this security testing now. And I'm just curious if you had a comment on that.
What do you mean devolve?
Well, evolve or devolve, right? It's, if you don't have the skills, you might view it as a de-evolution, or if you have it, then it's an evolution, right? So just because, the functional writing of security tests is more analogous to programming and that kind of stuff, which is potentially not, a skill set that typical security or some typical security resources might have or might not have.
So you think it should be taken over? This should be done by a dev team or a security?
Well, no, I just think it's a reality that it's going towards a development. We're all going to become developers to some extent. So,
okay.
I was just curious if that was.
Yeah. The reason I think it's a security team has this security expertise. We know how the vulnerability is going to manifest themselves and what's the best way to mitigate them. And the developers, they know their code, the logic. So I just hope we can marry these two together. So right now, I feel the best way is to have a security team to specify how this should be, make guidance on how to be tested, and it's up to the developer to write the actual test. I have example later. And lastly is a question for the audience. Does past result mean the risk is fully mitigated? For example, for the brute force attack, and we use the test cases, we make sure the account locking is working successfully after 3 or 5 tries. Does that mean that the risk is mitigated? I see Greg is shaking your hand. Could you?
Right, so okay, it's locked, but for how long? Do you lock it for 5 minutes, 3 minutes, 1 day? Can I keep doing it silently, right?
Well, you determine the control, right? If you determine you can be locked for even for 2 minutes, that's sufficient to mitigate brute force attack that account, right?
To some extent, yeah, but you could have it, yes, if your password is complex enough, but if it's in the top 100 bad ones, you might actually be able to cycle through 100 of them,
So
and eventually get like a password 1, 2, 3. Eventually, you might try it and it might actually work, right? So, not fully, but
yeah, it's a good point. Another countermeasure for this account brute force attack is instead of trying one account, you can try if your system has many different user accounts. Maybe you can only try twice per account, but you enumerate different accounts using some top password. Right? So there's still a risk here. So I think it's important to remember that even if your test case passed, it doesn't necessarily mean that the risk is fully mitigated. It just means that this security control is working expected. But there may be other threats that's not covered by this security control. So I think it's something we should bear in mind, that we cannot treat this security functional testing as the only mitigation, but instead really aware of the risk and combined with other security activities.
I guess as part of the risk equation is to, as you mentioned, the security control addresses one specific attack case. I'm wondering if, as part of what you do with your team, involves anything like developing attack trees to understand how an attacker might gain an objective. For example, if the risk is unauthorized access, brute force is only one attack pattern and one attack case. There may be other attack patterns that the attacker might try to use, and have you worked with attack trees to understand the different paths an attacker might take?
No, we haven't used attack tree yet. right now we mainly focus on the most important threads. Yeah, but that's probably the next level we need, we need to get to. Yeah. Here it shows another implementation. It's used in another system that we're building. So the basic idea is really similar to the previous one, but the difference is instead of report test case. Yeah, this is the CI pipeline, similar to Jenkins I showed you earlier. So instead of upload the secure test cases to Google Drive, we upload to this test case management system. This is a system we develop in-house. And then in turn, the test case management system will write all the record to Jira. So we use Jira to link the security requirement or threads with the corresponding test cases. And this is what it looks like. Oh, by the way, this also shows the one security thread or the test requirement I specified in Jira. So here we are trying to do a validation on JAD token. And here is the requirement. And then developer, they created all these test cases. As you can see, the test case management system automatically created these test case tickets and link them with these requirement tickets. And if you click each ticket, we will see each round to show the path of failure and the time. So this will be a good evidence when it comes to the auditing time. Okay, I don't think we have time to do exercise. So I just, as I conclude my presentation, I will skip this too. This is one of the most, this is one of the most common picture that I showed when people talk about the DevOps and the security. So basically means DevOps is the unicorn. Everyone loves it, but it's up to security team to shovel the shit, clean up the shit. I think DevOps does present a lot of challenges for security due to its speed. But on the other hand, it also presents a lot of opportunities. Like the iterative approach can be used by security to respond to security vulnerabilities faster. Like it's a stress on automation testing can be used by a security team to automate the security test cases. So I want to change our mindset and think we can, instead of blaming or complaining about the new process, we can embrace it and make use of all the good things come with DevOps and enjoy the ride. With that, that's all I got for my presentation. Do you have any questions? Okay.
Just on that last bit, in that having teams that are used to working in these quick iterative cycles back to vulnerability disclosure and getting external reports allows you to completely change that, right? Like when you're hearing about things on Project Zero Day and people complaining that it's taking companies 90 days or more to fix vulnerabilities, granted, it's different when you're patching, say, the Windows kernel than when you're fixing a small authentication bug in a web app. But on the other hand, the DevOps, embracing the DevOps can help you have that be part of the speed of your cycle of response as well, right? And we've seen huge improvements in the teams that have adopted XP, Agile, DevOps style coding within the company for when we get external reports. We're turning around test builds in days to the reporter and publicly being able to publish fixes, to the world in a fraction of the time we were used to under both the more adversarial model or the traditional waterfall model. So it can be a really good thing, right?
Yeah, definitely. That's a really good example. See, for DevOps, so far we didn't see the compromise of quality of the software much, right? So if they can do DevOps and Agile with fast speed without much compromise on the quality, and the security is only a special type of quality, why shouldn't we be able to do the same thing? So I think we can really embrace DevOps and use many good things there.
One of the traditional controls in days past is separation of your development and operations functions. So segregation of duties so that developers don't have access to production systems. And in DevOps world, that line gets blurred because dev can release into a continuous integration system that promotes things to production. That means while it allows legitimate code to hit the streets faster, it also allows problems or errors to hit the streets faster. So, can you talk a little bit about the how that segregation of duties control exists in the DevOps world and what the role of change management is there?
Oh, wow, it's a hard question. I'm not a DevOps expert, so I'm not sure if I'm the best person to answer the question. I would approach problem from the original intention of separation of duty. I think its original principle comes from the accounting or financial world, where you have someone to purchase and you have someone to approve the purchase. So we apply to this DevOps world a waterfall approach, where developer, we don't trust developer. So you can only build the code, but you cannot deploy to the production. I would ask whether this assumption makes sense from beginning. If you trust developer enough to run the code in production system, why can they deploy their own code? I think the control here should be really in the logging, auditing, so that you trust but you verify. Yeah, that's the best answer I can give you.
So here, I mean, at SAP, we do the same thing. We've got a kind of we have a DevOps, we also have a kind of a no-ops, especially with the microservices. I mean, it's as a developer, I know that, former developer, putting it backdoor is trivial, right? Static analysis isn't going to find it. So I mean, deploying in weaknesses would be very, very simple. So there's a trust aspect. I mean, there's certain controls that we have in place. The regular scanning that's in place, code reviews, full traceability of who checked in what, and everything like that. So we have some quality control, quality gates before developer can deploy. But theoretically, if they wanted to, I mean, they have some authorizations where they could probably go to production. We would detect that. But I agree with Yang. I think the old style of quality gates is dying. It's not going to scale. So yeah, the controls have to be in place, but you have to be just like agile, right? You have to move faster. These controls can't take 3 days of PDF reports and reviews. You have to compress that to a few hours max.
You can also have an adaptive model. I mean, in our world, for what, taking one product like antivirus. Okay, so antivirus, the definition that we ship from the lab, technically that's a program. It's written in a language we call the virus descriptor language. We're not shipping a signature the way you think of it. It's actually code, right? So we're shipping code constantly out of the lab all day long, and clearly that change control process, the old style, would be impractical, right? We'd never be able to send protection to anyone, and we have to trust that the labs people, they run through an accelerated test process that's designed specifically to catch the kind of flaws that would occur in that type of development, so that we don't ship a bad identity, but it's not going through this giant thing. But yet, for important code changes, even in the DevOps world, we have to test on 72 versions of Windows in simplified Chinese, and on and on and on and on and on. And that process takes a week just for the tests to run, and we can't skip that when we're doing important things that are changing other parts of the code base, right? So you can also break it down to things that are safe to allow that continuous evolving code to be shipping, and places where it's not safe and you need to maybe go through a more traditional change control process because the risk is so much higher. And I think it's like everything we talk about at every one of our meetings here, it's all back to risk management, right? We have to decide where is the big risk, where is the little risk, what's the risk of what the impact is going to be, and wherever possible, get it out of the way and let people iterate fast and ship code fast where it's safe to. But where it's not, sadly, you're just going to have to suck it up and do change control. Yeah, absolutely.
Because I mean, yeah, if you have a big monolith and you're a financial, company, changing something could be changing the UI, or it could be changing how you authenticate. But when you have a microservice architecture, again, yeah, to your point, risk controls, right? Is it an endpoint exposed microservice? Does it have 30 other services depending on it, or is this some sort of a, passive thing that isn't going to blow up, right? Yeah, I mean, you have to kind of have that awareness in place.
Amazon rolls thousands of changes a day, but if they had better change control process about shutting down the RAID array, we wouldn't have had a global outage for half a day. So I mean, it's that's the kind of thing you got to look at, right?
Yeah, I didn't mention earlier. In our process, for the feature, we also have this step called security SLRA, security risk assessment. So for those features, we first evaluate the risk level, and then we customize our security effort based on the risk level. And back to your point, if it's high risk, then maybe we go through more exhaustive test. If it's deemed as a low risk, why should we waste effort? Let people wait. And back to the quality gate, I think it's really important especially for auditors, to realize DevOps, this is really a culture change. Security shouldn't be treated as a gatekeeper anymore. Like, you have to fix this security issue before the product release. Why you still impose this requirement while you can you have multiple releases per day? Even if security issues are released to production, we can fix it quickly. Why do we have to stop the release? Maybe I know this is going to be a controversial topic, but I do want to impose the question on the auditors and all the people who think we have to fix all the security issues before the release.
I wouldn't say all, but I've done work in an editor capacity, and I think it's about knowingly releasing a product with significant security flaw. Even if you can fix it in 1 hour, that's still 1 hour that was exposed to the world. Again, it's about risk management. I wouldn't say all, but if it's a high severity issue and you know about it before going, but you still want to go ahead, that just from an editor perspective, it's not gonna fly.
Yeah. You're assuming it's high security issue.
Yeah.
You're assuming it's 1 hour, right? But there are many cases, it's a gray area. May not be that high severity. It may not take that fast to fix.
I think that in that aspect, I think auditors need to be more willing to approach it from a risk management perspective rather than a black or white approach. Yeah.
Is there's a culture shift between developers who kind of came up old school, and they do their work and then throw it to the test team, and then the test team would throw it to ops, and then that's their problem. In the newer world, you have to take accountability end to end for your code, and if there's an impact, you need to be held accountable for that impact and resolve it and fix it right away. And so getting around that behavioral shift in people is very difficult. The technology kind of works itself out, but that behavioral shift in how people work and are accountable is difficult.
Yeah, that's really another very important principle of Agile and DevOps. Developers, they are responsible end to end.
Red team, blue team to purple team, right? I mean, you find it, you fix it. And if you have to own the code, you think about finding things and reporting them differently than when you're just lobbing bombs over the fence. And vice versa, when you're writing code, you're a lot more careful when you know that you're going to have to be responsible for fixing it if you're the one making the errors, right? I think the more people play both sides of it, hopefully the more productive and the cleaner everything is in the end. Well, we should wrap up. We're out of time.
Okay.
So let's thank our speaker. And I hope all of you can join us for the last meeting before the summer break on June 9th. But if not, please join us in September for the AGM, where we'll be picking one of you randomly to be the president. And if we don't see you in June, have a great summer. And please volunteer. Let Rob know if you can volunteer to help us with Security Day. The CIO of the province would appreciate it, as well as Rob, who's volunteered to cat herd. So on that, have a great evening. Cheers.